als neue Mitglied des Alpenvereins vorstellen. Dann werde ich Météo France vorstellen. Und dann ich gebe einen Überblick darüber der Prognose der Lawinenrisikos in Frankreich. Und ich hoffe, das wird für Sie interessant sein. And now I switch to English because it's going to be much easier for me. So a quick presentation about myself. So I grew up in Basque country, so it's in the southwest of France, between Spain and France, by the Pyrenees chains. And just to give you an idea of what it looks like, it's quite hilly, but not quite the mountains. But we're very lucky to have less than, say, an hour and a half away by car, the higher Pyrenees, where we have, for example, Vignemale, which is my Lieblingsberg, or Gavarnie Circus, which is a UNESCO site. So I was lucky to grow up doing a lot of mountaineering. I did my studies in Toulouse. They call it the Pink Town because it's made of bricks, still not far from the Pyrenees. And I actually studied geography and remote sensing. After my studies, I moved to London, and I was interested in snow and ice, so I decided to do my PhD in that topic. And I was mainly interested in the optical properties of sea ice for climate change. So since there's no sea ice in England, we had to bring it to London. And so we made our own in indoor laboratory. And then I also had the chance to go up to some countries up north, like Greenland, to do some measurements. When I finished my PhD, I moved to Grenoble in the Alps, and I joined Météo France at the Center for Avalanche Forecast. And there I was mainly working for several years on the properties of snow and how you can measure them from space to improve the models. So this was based on a lot of observations in the field. I was very lucky to have my bureau in Col du Lautaret, and also looking at a lot of satellite images. And I came up with this model that shows how light reflects in the mountains and how you can measure this. Then last summer, I got a new job, so I jumped on the train and I came to Graz, and I've been loving it since. And I came here to work at a company called Sentinel Hub, which basically helps people use satellite imagery to study the Earth. And one of the things I'm working on right now is a cartography of snow depth across the whole Alpine arc. And this is a product that we hope that will come out in the next few years, which would be really cool for users such as skiers or people in mountain clubs. And obviously, the first thing I did when I got to Graz was I ran to the Alpenverein to become a member. Unfortunately, I haven't had the chance to meet anybody yet, but that should come soon if things get better. So now just to give you a few words about Météo France in France. So overall, the activities are mainly weather forecast and warnings, and also looking at the past climate and doing climate predictions for the future. I guess it's very similar to the ZAMG in Austria. How do they do these forecasts? Well, with a lot of observations, a lot of modeling, high technology with like satellite images and supercalculators to model the weather. And then there's a large area for research and expertise. And these products are mainly for citizens, the public powers, and then some aeronautics or defense. And the way it works, and I think it was interesting to show you this because I think it's very different in Austria with the different Bundesland, is that Météo France is centralized. So it's partly governmental. So it has public money, but also can do private projects. And then it's split up into regional centers for the different forecasting of weather. And we also have a presence around the globe in the French ex-colonies, which are very useful for doing marine forecasts, especially for hurricanes, etc. But this doesn't really interest you. What interests you is the snow. And for snow, we actually have 8 forecast centers that are distributed across the different mountains. And then everything is centralized to 2 regional services, one for the Alps and one for the Pyrenees. And then there's one national service in Paris, because they always have to have a center in Paris in France for every company or every service. And then the research center in which I worked was in Grenoble. So the actual research center in Grenoble is called the Center for Snow Studies. And I'm showing a very nice picture of Grenoble and not the building, because it's a horrible concrete building somewhere. So I thought I might put a nice picture of the town instead. And actually, the center, by law, is obligated to monitor the snowpack, predict the evolution, and communicate this information. And they don't have a choice, they have to do it. And to do this, there are 5 teams working in Grenoble. There are 2 research teams, one that looks at the weather and the snow transport by the wind, and then one that looks at microstructure, physical properties of snow. Then you have 3 operational teams that are completely focusing on the forecast of avalanches. So I'm going to give you an idea of how you forecast avalanches in 3 parts. So I'm going to look at the past first, then we'll look at the present, and then quickly at the future. So in France, there were a couple of studies that started on avalanches in the 50s. And the reason for that is because you have people in the mountains. But before that, not enough to justify forecasting avalanches. But in the 50s, EDF, so the national electricity company, started building a lot of dams, and there were a lot of workers that were going to the mountains to build these dams. So they did a few studies on avalanche risks to protect the workers, but this was just private. Then in Grenoble in 1968, you have the Olympic Games, and that was the first step in avalanche forecasting. And not because you had to protect the areas where the Olympic Games were taking place, but more because it brought a lot of people to the mountains. And so with this sudden increase in people in the mountains, you had to start thinking about the risks of all these tourists were taking. But the major event, unfortunately, was a big accident. And this is what really started the operational forecast of avalanches in France. It was the 1970s Val d'Isère accident. And what happened was that an avalanche came down all the way through the village and destroyed a house where you had a group of young people that were on holiday there. So like a junior club. And it killed the 42 children that were in the house. And this really triggered the creation of a surveillance and warning program by the state. So they created a special section for avalanche forecasts, and they put in place some partnerships between ski resorts. A little bit more, and so this is like an official mandate for us to monitor and forecast the avalanche risks. In the 80s, there were a lot of different regional centers that were created in almost all the different valleys in the Alps and the Pyrenees. But then as everything, this costs money, and in 2013, there's been a big reorganization and everything has been re-centralized to just 2 main forecast centers. So the question is, how do you forecast avalanche risks? Well, if you want to know about the snowpack, you have to observe it and look at it. So avalanche forecasting is mainly based on observations. So point observations of the snowpack to see how it evolves through the season, but also weather observations, because weather in mountains, as you know, is very, very variable from one valley to another with different topography and configurations. The problem of only having observations is you have a very strong variability that the observations can't cover. So if you look at the snow in one valley, it's not the same as in the other side of the valley, for example. And so you also rely on modeling to forecast avalanches, because the models give you the ability to closely follow the temporal evolution of the conditions all throughout the season and across the whole range of mountains. And also it's a good representation because we understand very well the physical processes within the snowpack. However, you have difficulties with uncertainties, and actually the 2 go together, because to model the snow correctly, you need good observations. So let's look at observations. Here is a map of the French part of the Alps, and Météo France have 140 observation points across the 3 big mountain chains in France. And these are mainly automated stations or manual measurements. So there's a very close historical collaboration between Météo-France and the ski resorts, and this is not commercial. It's more of an exchange. So Météo-France gives the gear, the training, and in exchange, the ski patrollers, they give something that's very valuable, which is time. And so they offer their time and their service for free, and then there's a sort of exchange, and then they benefit as well from the products. There are a few historical positions where you have employees whose job is just to look at the snow every day, and I find that's a really cool job, but there are only like 2 or 3 left. So how do the ski patrollers communicate the observations? Well, first of all, every day they go around the resort and they give general observations of the weather conditions, and then they look at all the avalanches that happen around the resorts. Then every week they do a snow stability test. So I think that it's actually a German word, the Rutschblock, we call it in France. And then also a full profile of the physical properties. So that means all the layers you have in the snow, what type of grains, like the grain size, and then the density and temperature of snow. But if you look at the map of ski resorts, you often have big holes in some areas which are not very habited, and you need more information. And for that, we also rely on a very dense network of automated stations, and they give measurements hourly. So they give snow depth, temperature, humidity, and wind. They have to be autonomous in energy, so they rely on solar panels and batteries, and they transmit automatically through iridium technology. You do still have problems with these. For example, some can get buried some years when you have a lot of snow. Then it's very difficult to measure snow height. Or sometimes when it's very icy, they can ice up and then they stop working for a few days. Here's an example of an output of these weather stations that anybody from the public can access on internet. And you have at the top the wind over a few days, and then you have the air temperature in the middle, and then the snow height, which is measured with an ultrasonic sensor. All these observations, they're sent to a centralized system. It's put in some computer system, and then the experts use this information to have an idea of how the stability of the snowpack is. And so individual ski resorts also have their forecasters, but they only work at the local scale, whereas at Météo-France, we work at the Massif scale. What we call the Massif is actually a group of mountains. So it's like an area of mountains that makes sense to be put together. And so the forecasters, they tend to trust observations. They don't really trust models for historical reasons. It's because before models didn't work very well. Now they work better, but the forecasters who work at Météo-France don't really trust them. But if we actually look at the modeling, there is a modeling chain that is in place. And it's based on 3 models, actually. So you have mountain weather, a snow model, and then the risk analysis. So for the mountain weather, it's called Safran. And actually, you have several inputs into the model. So you have, on the left, you have the Lamare weather station. So it has all information about the local weather in numerous points. At the bottom, you have a radar, weather radar station. It uses information from this station. And then also satellite imagery, as you can see on the right. And then at the top, you have some large-scale meteorological models that come as inputs. It does its calculations, and then it outputs for each massif, so each mountain area, 9 parameters, which are wind, temperature, humidity, precipitation, solar radiation, clouds, etc. This is great to give you an idea of what's happening now, but for the future, it can't rely on these sources of observation because they don't exist for the future yet. So when you're predicting, you're only using the large-scale weather forecast. This information is then transmitted to Crocus, which is a snow model. So it's a physical snow model, and it basically simulates the snowpack from the start to the end. So the reason you need the weather is because there are a lot of interactions between the atmosphere and the snow. So you have radiation, you have precipitation, you have turbulent fluxes. And so these are the inputs from the weather model. Then Crocus actually considers the variables inside the snowpack. So it looks at heat fluxes, thermal diffusion, water flow, etc. And it builds up the snowpack, and every day it calculates a new run, and then it follows the evolution. And so here you have just some example graphics of how you can predict the evolution of the snow. And we're quite good actually at getting when there will be no snow anymore in the mountains at the end of the season. So we can predict the snow all across the season. This is just an example of what it looks like. So you can see across time, the model is two-dimensional. So it builds up different layers that have different properties. So for example, at the base, you might have something like depth hoar that stays throughout the season. And then you have the fresh snow in green that actually lands on top of the snowpack. Then it gets older across the time as you go along. And then you have more fresh snow. And this is a representation. All of this then goes to what we call MEPRA, which is a risk analysis software. And what MEPRA does is that it allows the experts to explore all the facets of data set, because there's a huge amount of data set. And if they had to look at everything individually, they couldn't understand what's going on. And so what MEPRA does, it takes the internal properties of the snowpack and it identifies weak layers or areas where you could have a risk of, for example, Triebschnee, I think it's called, or Altschnee. And then it outputs this information for the different mountain range at different altitudes and for different expositions. And so this is how the forecasters have an idea, and they use this tool to sort of try and give the best forecast they can. This forecast is then sent directly to professionals, so the guides or the local Alpenverein in France, which is called the CAF, and directly to ski resorts. The general public also has access to updates twice a day at 9 o'clock in the morning and 6 o'clock in the evening. And then you have special reports in case of great danger, which means when the risk of avalanche is 4 or 5. And then lastly, all these model outputs go into research to make the models better, and also for criminal investigations. So when you have an avalanche, there's always a criminal investigation by the police after to know what happened. And Météo France are the experts that then go to the trial, if there is a trial, for example, or who will decide if it was a responsible accident or an irresponsible accident. Maybe this can interest you. This is what the forecast looks like. So you start with the classic risk level and the altitude of risk where it changes. And I've seen that it's quite the same here. And then the most dangerous orientations. You have a summary, and this is quite nice. You have actually, these summaries are written twice a day by some experts, and they often give their advice. And then you have some extra information. So when was the last snowfall? When is the next snowfall? What the weather will look like? How much snow you have at different altitudes on the north side of the mountains and then on the south side, plus a skiability text. So this is like, how good is it for skiing? And then lastly, you have the evolution of the risk and of the weather over the last week. So this gives us quite a good idea of how you can actually, how the conditions were, and this gives you a good idea about what they are now. That's a present. So there are a few limitations. As I said, the forecasters don't really trust the models, and we are working a lot to think, how can we make them better? Because for now, they're quite simplified. And actually, the models see the mountains as very basic pyramids, right? So they look like something like this. So with different orientations, different altitude bands, and then you get one information per altitude band and per orientation. And now with the super calculators we have in France dedicated for these computations, plus the advanced knowledge in research to make the models more performant, we can move on to a distributed simulation. So that means that we would simulate it per areas. And these grid areas, what we're aiming for is 250 meter resolution. So every 250 meters, you get a different information. The next big step is satellites. So the European Union has launched a lot of satellites in the past years, and this is a lot of free data that's available. Actually, you can actually go online and download whatever image you want. It's completely free. And we really want to use this as observations to add into the modeling to make it better and to help the experts forecast. The two things is that satellites can give you a good overview of the whole chain of the mountains in one shot. So that's great to see how the conditions are changing across the mountain. And then you have some very high resolution satellites where you can look at a very specific area and it will give you a better idea on the snow cover or the snow conditions. You can calculate the physical properties of the snow from satellite images. This was actually my job when I was there. And this is a very interesting graph. I like to show it because in red, so let's look at the top one. In red, you have the actual measured snow depth across the season. And in gray, you have the uncertainty of the model. So you can see that as the season goes along, the uncertainty of the model gets larger and larger. And at the end, you're not sure if the end of the season for this area is actually in end of April, early April, or end of March. But when we inject the satellite images into the model to improve the model and tell the model how the conditions are, then the uncertainties become the blue lines. And as you can see, we really improve the knowledge of the snow height across the season using satellite images. But this is still a research phase at the moment. So this is like exciting new developments for the next years that are coming. Just as a conclusion to this talk, so that I stay on time, I'd say that Météo France is a very large infrastructure, very heavy, but that's good because it allows you to do very advanced things in terms of operational forecasting. We cover all the mountain ranges. However, it's not so good because, as many administrations in France, it's too heavy. And so the system is very slow to evolve. The research and the operational sides don't communicate very well. So there's a lot of work to do on this side, bringing new technologies into snow forecasting. And actually, this last figure here, I found it really interesting. It has nothing to do with my talk, but I thought it might interest you. It's actually the evolution over the years, so from 1990 to 2011, of the number of people killed in avalanches. And what you can see is that although we have a strong increase in number of people going ski touring or number of people going skiing and free riding, you have more and more every year. The number of people that die from avalanches stays quite constant. And that means that one, people are becoming more aware and being more careful, and two, that through our services of prediction of avalanche risk, we seem to be doing a good job because we're communicating this as much as we can to the public. And you can kind of see that in these numbers in a way.